So this is Lab 7, Enzymes, Part pH. So the procedure, we first started by filling the 7 test tubes with phosphate buffers of 2 pH, 4 pH of 4 and 6, 7, 8, 9, and 10. We thought that going in increments of 2 for the majority of them would give a decent balance, and we know that the pH of 7 is neutral, so that would be a decent fit. After that, we filled each substance with 1 milliliter of potato extract and let that stand for about 5 minutes. And so what that did was the potato extract had the enzyme in it, and so we let the pH take the effect on it, and then we added in the catechol, and we got to see what happened after 3 to 5 minutes. So this is what the buffer with the enzyme looked like beforehand. Looks fairly white or clear. And so as you can see here, and with my horrible arrow, that number 3 is the darkest of all test tubes, and what that means is that it had the highest rate of reactivity. So our hypothesis was that the catechol would function optimally at a neutral pH of 7 because it would neither be acidic nor basic. However, in our conclusion, you can see that it was actually the pH of 6 that had the most coloration and the most reactivity. And we concluded that a pH of either 2 or 4 was too acidic, and it essentially denatured the enzyme. And at the neutral pH, it actually had fairly low reactivity, and pHs of both 8 and 10 still reacted, but were in the optimal pH. And for the pH of 12, it was obvious that the buffer was too basic. And the reason we could tell this is because if you go back to this slide, both test tubes 1 and 2 were white, and along with test tube 7, so because they had basically essentially no coloration, the enzyme just didn't work because it was denatured. And then the other 3 right here all were about the same, but we concluded that the pHs of 8 and 10 were a little bit darker than the 7. So that concludes the pH test of Lab 7 enzymes.